So in this class I just want to do another quick recap on a few things to do with linear relations. Remember, linear relations produce straight line graph. Here's a very well known linear relation. This is the conversion for Celsius into Fahrenheit in temperature. So to find the temperature in degrees Fahrenheit, you multiply the temperature in degrees Celsius by 9/5 and then add 32. So, you take a fifth of it, then multiply it by 9, and then you add 32. Here I've put in temperature for some reason in degrees Celsius on the y-axis, temperature in Fahrenheit on the x-axis. If I want to find the temperature in Fahrenheit, it's 9/5 times the Celsius temperature plus 32. Note here, based on my graph, this would be x equals 9/5 times the y coordinate plus 32. So this is not really in slope-intercept form. So the x coordinate here, I've got temperatures in degrees Fahrenheit. So this is telling me my x coordinate is equal to 9/5 times my y coordinate plus 32. So to convert from Celsius into Fahrenheit, if I pick some value in Celsius, let's take 10 degrees Celsius. Notice temperature in Celsius here in the y. Well, my temperature in Fahrenheit is going to be 9/5 of that. Well, 1/5 of 10 is 2. If 1/5 of 10 is 2, then 9/5 of 10 must be 18. 18 plus 32 sums to 50. So we're looking at 10, 50 away out here. So 10, 50 is going to be a point on this graph, 10, 50. If I look at 0 Celsius, well, 0 Celsius, 9/5 of 0 is 0 plus 32. That's 32 degrees Fahrenheit. So 0 Celsius, which would be down here, will give me 32 degrees Fahrenheit, which would be over here. 32 degrees Fahrenheit. And I can draw a straight line through those points. I could generate other points. If I go to negative 10 degrees Celsius, well, 9/5 of negative 10, 1/5 of negative 10 would be negative 2, so 9/5 would be negative 18. Negative 18 added to 32, well, that would be 14, so negative 10, 14. So I can kind of develop a picture in here. I can start to generate some points. So again, let me just mark in the coordinates of these points. This is 14, negative 10. That means 14 degrees Fahrenheit is equal to negative 10 degrees Celsius. Over here I've got the point 32, 0. So 32 degrees Fahrenheit is equal to 0 degrees Celsius. Out here I've got the point 50, 10. So 50 degrees Fahrenheit is 10 degrees Celsius. We could start to establish a relation. The other thing I might be interested in doing is changing the subject of this formula. And I can do that first by subtracting 32 from both sides. So we get the temperature in Fahrenheit, subtract 32, will be 9/5 of the temperature in Celsius. And multiplying on both sides by 5 and then dividing by 9, I'll get 5/9 of the temperature in Fahrenheit minus 32 will give me the temperature in Celsius. Okay, so 5/9 times the temperature in Fahrenheit minus 32 will give me my temperature in Celsius. Okay, so that's how we can convert then Fahrenheit into Celsius. Pretty straightforward from there. You can take your Fahrenheit measure, plug it in here, and find your Celsius conversion. So if I go back to my 32 here, plug 32 in, 32 subtract 32 is 0 times 5/9, 32 subtract 0. Okay. Again, I can draw a straight line graph through these points, and you'll see it does not contain the origin because it is not a direct proportion. That's what my straight line graph will look like. Going down somewhere like that. Okay, and you'll find my pencil is probably a little bit too thick to be 100% accurate, but as accurate as I can really get it, I suppose. computer would generate this a little bit more accurately. So what is 0 degrees Fahrenheit? If I want to figure out what 0 degrees Fahrenheit is, well, I plug in 0. The temperature in Celsius would be 5/9 of 0 degrees Fahrenheit minus 32, which would be 5/9 of negative 32. 5 times negative 32, well, that's negative, I think it's 160 over 9. So negative 160 over 9, well, 9 goes into, it's going to be negative, 9 into 16 goes once, 7 over, 9 into 70 will go 7 times, with a remainder of 7, 17.7. I think that's possibly going to recur. So 17.7, so that's not quite 18, negative 18 then there, it's negative 17.7 recurring. Okay, and so this is, given some kind of equation, we can often come up with a linear relation. This is not a direct proportion since it does not pass through the origin. It has a non-zero y-intercept. Sorry, that's not slope-intercept form. It has a non-zero y-intercept. Okay, if it was a direct proportion, one of the variables could be written as the other variable multiplied by a constant. Always, there would be no kind of addition in here at the end like this. Okay, so practice those. Section 4.8, get familiar with all these things, and that concludes our work in chapter 4.